This compromise is literally one of the worst case scenarios for the world of NPM supply chain breaches. Today we're talking about Axios. Axios is a very hugely widely used project in the world of the NPM ecosystem and JavaScript. Now, if you're not aware, Axios has 101 million weekly downloads, okay? It is one of the most widely used packages in the world of JavaScript. We're not gonna go into the whole holy war between Fetch and Axios. If you're in JavaScript, you're very aware of the fact that there is a war between these two APIs. It's a 3-year-old discussion that I'm not going to go into. I'm not a front-end guy. I will say, however, that I, on Low Level Academy, use Axios, but because I'm a bad system admin, I didn't update, and therefore I was not compromised. Now, how did we get to a place where Axios get compromised? What's going on here? How did we get here? The story of this compromise starts like pretty much any other NPM or PyPy package compromise goes. One of the maintainers, and in this case the lead maintainer, Jason Saman, got hacked in some capacity. No one really knows the exact time and location of the breach, but Jason got hacked at some point. And using his account, the hackers manually published 2 backdoored releases, Axios 114 and 034, tagged latest and legacy, that included a phantom dependency. They injected a dependency into an already existing package. Package in question here is plain crypto.js, which at face value looks like a very normal package, right? Well, under the hood, what plain crypto.js actually is literally just a copy of regular crypto.js, which is a project on GitHub used to allow you to do a variety of crypto algorithms like MD5, SHA-1, SHA-256, all of the symmetric ones like AES, DES, etc. What they did with plain crypto.js is they took crypto.js, they wrapped it in a little wrapper, and then inside of plain crypto.js, they hid this little post install script. Now, as the socket repo viewer shows you, install scripts are run when the package is installed or built. Malicious packages often use scripts that run automatically to execute payloads or fetch additional code. Probably should be wary of those. Now, I want to highlight it is a feature, not a bug, to have code that has a post install script, right? If you have a repo that you download that maybe depend on a certain property of your computer, right? It's smart to use post install scripts. You run some script after the project is installed to get it set up properly. This is fine behavior. What's not fine behavior is the code that gets run when you run the post install script, setup.js. Now, surely setup.js just sets up the package, right? Well, setup.js is obviously, as the title of the video kind of implies, it is a piece of code that runs, that checks for your current OS, downloads a current specific version, downloads an OS specific payload for your computer, and then runs that payload on your computer and communicates all this information back to a remote C2 server, with this URL here being the C2 server. It's sfrclack.com port 8000. And then ultimately that malware goes through your system, whether you're on Mac, Windows, or Linux, and is doing a basic reconnaissance of what files you have on your computer. I don't think there's actually any indication that the files are being extracted. I think maybe there was an intent for the malware to run for a long time and then to kind of pick and choose who they slurped up data from. What's interesting about this compromise, by the way, is Jason here is commenting on the issue within Axios where they're talking about the compromise. And he says, I'm trying to get support to understand how this even happened. I have 2FA multi-factor on practically everything I interact with. What's really terrifying about this statement is that, like, Jason is obviously a security aware person. He's a contributor to a major package on GitHub, Axios. He's like the lead maintainer of this package. And even he, a person that uses 2FA and MFA, it's been compromised, right? Now, Step Security went into kind of the details of the nature of the publishing, right? So again, Jason is a maintainer. To be able to publish on behalf of Axios, you have to have the NPM token or credentials of a maintainer of that project, okay? So if you go to the metadata surrounding a legitimate post, right? Like Axios 1140, for example, when you do this kind of publishing using a token that has 2FA, a modern token, typically you get this OIDC binding, right? So you see there's a little bit of metadata that is around a trusted publisher, and it shows you that the publishing came from GitHub and has this OIDC config, right? So there is likely a GitHub CI/CD pipeline that ran, pipeline past the build, and then the token inside of that action workflow publishes it to NPM. The publishing of 114, which is malicious, you will notice has none of this metadata. Now, what step security is asserting here is that to do this, the attacker must have obtained a long-lived classic NPM access token for this account. What this means is it's entirely possible that sometime in the past, we don't know how long ago, Jason's computer may have been compromised a while ago by some other variant of Shai-Hulud, a PyPy compromise, etc. And the attackers may have gone just like this malware goes, right? It kind of just does a light recon of what it's seeing and says, oh, wait, I'm on the desktop of Jason Saman. I need to collect all of their credentials. And then they may have sucked up a legacy token a long time. It's important to highlight that while NPM has completely revoked their entire legacy access token system, where a single token gave you access to all repos with no granular control, with no ability to kind of down select what things you can and can't access, since 2025 November, granular access tokens are still supported. They're legacy tokens that give you the ability to down select on specific repos, read, write, and IP address ranges that behave sort of like the newer tokens that give you the ability to use 2FA. Important to highlight that granular access tokens do allow you to bypass 2FA requirements. For example, if you want to be able to publish the repository to NPM through the completion of a GitHub action, it may be required to use a granular access token. Now, again, you can publish to NPM using the trusted publisher system using tokens, right? All I'm saying is that it is possible that a legacy token that exists from a long time ago may still be floating around and was used by the attackers to impersonate Jason Saman and ultimately hack the repo. That being said, there's a variety of ways this could have gone wrong, right? Jason could have been hacked. There could have been a GitHub action workflow that was misconfigured, that when you committed code to Axios, you're able to read tokens out of the repo. There's a lot of ways this can go south. Unfortunately, this is kind of the nature of token-based auth, right? Once a token goes out, unless you explicitly revoke that token, it still retains the authorities that it has, right? So if you don't know that it's compromised, there's no reason to destroy it. Now, if you're in the world of defense and you need to be actively looking out for this, if you're a person that maintains a project that uses Axios, these are kind of your IOCs, right? Depending on what platform you're on. So obviously all the C2 that we know about so far talks out to this location here, this hostname and port 8000. The post install script is going to be a setup.js with this hash itself, and then the payloads that actually run initially as like the initial rat are these paths here with these hashes. I'm sure they're floating around all over the place. I have Ox up, for example, so go check out Ox if you want to check out the hashes. Oh, also remediation, obviously, if you are on the 1 branch of Axios, install 114. If you're on the 0 branch, use 033, because 0.1 and 0.4 are compromised. That's what you got to do. Guys, I want to highlight here, I think we're beginning to see kind of the nuclear bomb effect of the world of package managers, right? We're seeing this with NPM. We're seeing this with PyPy, where packages get compromised, people download those packages, that installs malware, right? That malware is able to then consume the local files of those people, and some of those people are maintainers. That causes malware to spread to new packages, acting kind of like a nuclear fission effect, right? And more people, more and more packages get compromised. This is the inherent vulnerability with languages that use packages like this. Now, I'm not saying don't use pip, don't use npm, don't use Python, don't use JavaScript, right? This is kind of the nature of software today. And I think the reason that we're seeing attackers move to this model of attacking open source software, I think software that's manually memory managed, like C, for example, I think because of a variety of mitigations put into tool chains and just hardware-based mitigations like control flow guard, tagging extensions and ARM, etc., we are beginning to see a world where like software is getting pretty secure. Dropping a 0-day on the latest iPhone is a project that takes a long time, and the payout for that from Apple is $1 million, right? It is much more difficult to get into somebody's iPhone via a memory corruption exploit with a sandbox escape to get into the kernel versus just, oops, Jimmy from down the street got hacked and he's the maintainer of giant JavaScript project.js, and because of that, now you can just get into that person's network, right? You can be in their computer. Oh, and also, by the way, in that computer, they do very sensitive work like maintain a different project that other people also use. Very scary stuff. if you even think you've been a part of this, if you think that you have been compromised by Axios, first of all, you'll know probably, right? Go check your package lock on all of your projects. And if you're even just nervous, right? Go through, rotate your API keys, change your credentials so that even if you got hacked, the downstream kind of second order effects aren't so big in your life to the point where like your stuff is getting further compromised and then eventually your customers, right? And also, if you're still here, you're a real fan, which means you probably want to know what I'm doing next. I'm a guy that owns a microphone, which means I qualify for a podcast. If you want to subscribe to The Lowdown, my new podcast coming out next month, go check out the link in the pinned comment below. Anyway, guys, that's it. Thanks for watching. I appreciate it. As usual, see you in the next one. Take care. Goodbye.